Alright guys, welcome back to the fourth episode of this Java tutorial. This is my second time filming this video because the first time I made quite a few mistakes. This time I'm gonna not try and make those same mistakes. Yeah, let's get right into it. So, logic, comparison operators, and Booleans is what we're gonna talk about this episode. I made the mistake last episode of calling them comparators. That's not accurate. They are comparison operators. And the other thing is logic operators as well. I got that wrong when I filmed this last time. Right, so start with logic. Logic was first invented by the ancient Greeks, and it's sort of a way to figure things out using true and false statements. And it's sort of like saying, if this is true and this is true, then the whole statement's true. Or if this is true and this is false, then the whole statement's still true. I know it might sound weird right now, but it'll make more sense when I get into it. So the first thing we need to cover here is an if statement. So to write out an if statement, we just write if, then we have something in these brackets, and then we have these curly brackets, and then any code that goes here, that is going to get run only if a condition is met, and the condition is what we put in between these two brackets. So let's say if true. Now this is always going to run because true is true. If false is never going to run because false is not true. If 1 is equal to 2. So I'm going to introduce you to a comparison operator called equals equals. 1 equals 2. So this says, does the first thing, is that equal to the second thing? Now it's different than the 1 equals sign. It has to be 2, because the 1 equals sign is setting a variable. This is not setting a variable, this is comparing two things for comparison. So if 1 is equal to 2, that's not true. If 1 is equal to 1, that is true. This code will run. What about if 1 plus 1 is equal to 2? That would work as well. That's another valid thing to put in the if statement there. So, let's just leave it like that, and I'll just show you to prove that this works. System.out.println. Congrats, math is not broken. Let's run that. Congrats, math is not broken. Alright. And just to prove that if 1 plus 1 is equal to 3, it shouldn't run. Yep, see, it didn't run. Right. So we have these comparison operators. What's another comparison? Well, we can say if they're equal, and we can also say if they're not equal. So 1 plus 1 is not equal to 3. How do we check that? Put an exclamation mark in front of your equals sign, and that is a not equals. Let's just space this apart to make it a little easier to read. 1 plus 1 is not equal to 3. So if 1 plus 1 is not equal to 3, print congrats, math is not broken. So this should print congrats, math is not broken. There we go. And another operator, another comparison operator, is greater than. So is 1 plus 1 greater than 3? Well, no, it's not. So nothing should run. Nothing. Okay. Is 1 plus 1 less than 3? Yes, it is. Congrats, math is not broken. And what else? How about 1 plus 1 plus 1 is less than 3? Well, 1 plus 1 plus 1 is equal to 3, and 3 is not less than 3 because it is 3. So nothing should run. So what if we wanted every number that was below 3 and including 3? Well, we would say less than or equal to. That's how we define that. That's how we say that. Congrats, math is not broken. Likewise with greater than. 1 plus 1 is that greater than 3? Well, no it isn't. so it's not going to do anything. But is it greater than or equal to 3? Yes, because it's equal. Congrats, math is not broken. And those are the comparison operators. Now we also have logic operators. That's the other thing you can do in the if statement. So if 1 is, so this is when we're dealing with true and false. So this whole thing will run if the overarching thing in these brackets is true. The whole statement is true, and this will run. But we can kind of break that apart into smaller things, where some of them are going to be true, some of them are false, and then we can make an overarching decision whether the whole thing is true. So we can say if 1 plus 1 is equal to 2, which is true, and 2 plus 2 is equal to 4. In case you wanted to check both of these things. Now this and, it's 2 ampersands. This means that both of these things have to be true for this to print, which it will. Congrats, math is not broken. But if it was 2 plus 3 equals 4, which is false, this is still true, but this side is now false. And since it's and, you can't have a true and a false and have it be true, it becomes false. It won't run. The other option you have is or. So with or, only one of them has to be true. It's one or the other. If both of them are true, that's just as good. If none of them are true, well, neither is true, so it won't print. So is if 1 plus 1 equals 2 or 2 plus 3 equals 4, then print congrats, math is not broken. Let's give that a try. See, congrats, math is not broken. Even though this is just completely objectively false, this is still true. So the whole statement becomes true. And I think that wraps it up for logic operators. Now I'm going to talk about Booleans. So, like with ints, like with strings and doubles, there is another type of variable you can make called a Boolean. And Boolean is very simple. It's just true or false. So let's say Boolean statement equals false. Let's call it actually statement 1. Then Boolean statement 2 equals true. And now remember, we're using 1 equal sign here because we're setting a variable. 2 equal signs is to compare. So now let's try this. If statement 1 equals true, did I spell that wrong? Statement. There we go. If statement 1 equals true, then print this. So it should print. Except it does. Oh no, it's that's what I meant to do. Congrats, math is not broken. Okay, because statement 1 is true. But remember what I said earlier. It's checking whether the whole overarching thing is true. So we can actually get rid of this. We only need to know if statement 1, because statement 1 is true, and it will run. But if we set this to false, it won't run. And just like earlier with my math things in the if statement, these Booleans will also work with ands and ors. So you can do if statement 1 and statement 2, they will both have to be true, which they aren't, so nothing will print. But if we make them both, then it will. And if we make one of them false, but if we change this to an or, it will print. This the symbol for or, by the way, is like a pipe. It's called a pipe. Individually, they're called pipes. And you can find it on your keyboard. Mine's above the enter key. Yours might be somewhere else, but you should check that. So what if we want to then, if this isn't true, so let's go back to and. If we want to say congrats math is broken, we need to have else. So if this is true, print this, else print something else. This is how we write else. Just like that, it's sort of part of the if thing. And then system.out.println, oops, math is broken. You shouldn't actually say something like that. I should probably just say, oops, you put the wrong thing in. And yeah, so since these aren't both true, this is gonna be false, but this, else, it's gonna print. So, oops, you put the wrong thing in. There you go. I think that wraps it up for this episode. Yeah, I've covered everything that I want to. We learned about logic, so true or false, and an or. We talked about comparison operators, greater than, less than, equal to, not equal to. Oh, how about another interesting thing to know? If you wanted to invert a Boolean, so say you've got statement 1 is false, but say you in this case you want statement 1 to be true, you can put an exclamation mark in front of it. Let's put it in front of both, and this will invert both of them. So statement 1, this inverse statement 1 is now true, this inverse statement 2 is now false. So let me just prove to you. So statement 1, true. Without this exclamation mark here, this will go through and say, congrats, math is not broken. With this, it will say, oops, you put the wrong thing in. Let me show you. Oops, you put the wrong thing in. I get rid of it. Congrats, math is not broken.